Hello friends, myself Kamna, Assistant Professor in Computer Science and Engineering Department in AKGEC Engineering College, Ghaziabad. Today we are going to discuss the mode of transfer. Mode of transfer are actually three types, that is a programmed I/O, DMA and interrupt initiated I/O. Today we are going to discuss the types of mode of transfer, that is programmed I/O and DMA, that is direct memory access. And these topics is covered by Computer Organization and Architecture subject. Actually, mode of transfer is divided into three types, that is a programmed I/O, interrupt initiated I/O and direct memory access. So, today's content we are going to discuss these three. What is mode of transfer? Mode of transfer, actually the peripheral devices. First of all, we have to know what is the peripheral devices. Peripheral devices is actually the input-output devices. Whatever the input device or output device, these are the peripheral devices like mouse, keyboard and your display unit, that is your monitor. All these collectively called as a peripheral devices. Actually, peripheral devices is not directly connected to the memory. So, there is some mediator is required. Actually, when peripheral devices is communicating with the memory, there is a processor is in between there. So, any data is transmitting from peripheral devices to the memory. First of all, it goes to the processor, then processor sends this particular data to the memory. Actually, the problem is that only that the peripheral is not directly connected to the memory. And why it is called? Because the peripheral devices, the efficiency, the speed, all these things are the different from the memory or the processor. So, there is an interface required. So, in this particular mode of transfer between the central computer and the I/O devices, it is handled by the various of modes. Some modes uses the CPU as an intermediate path and other is transferred to the data directly to and from the unit. These are the three particular programmed I/O, interrupt initiated and direct, that how peripheral devices is communicating with the memory. This mode of transfer is actually explaining that how because the in between there is a processor is including. So, and the processor is also busy with other activities. So, how we are going to handle? Let's discuss. The first is the programmed I/O. In the programmed I/O operations, the result of the I/O instructions written in the computer program. Each data item transfer is initiated by the instruction to the program that it goes to the processor and then processor sends this particular data to the memory. Other instructions are also needed to transfer the data to the CPU and the memory. So, transferring the data from peripheral devices through CPU to the memory is by help of this particular mode of transfer, that is the programmed I/O, the first. And the second is, but in the programmed I/O, actually what happened, that when the peripheral device is sending the data to the memory, actually, so program in mediator there is a processor is there. So, programmed I/O sends data to the memory and then CPU and then to the memory. In between there is what happened is there, that in the programmed I/O, whenever the data, always the CPU is always busy to checking the flag that when there is something data is to transmitting from peripheral devices to memory. So, always in the programmed I/O data transfer, CPU is always busy for checking that there is some data to transfer from peripheral devices to the memory. So that this particular drawback will be overcome by the interrupt initiated I/O. In the interrupt initiated I/O, what happened? In the interrupt initiated I/O, in this time, CPU is not always busy. Whenever the data is transmitting by the peripheral to the memory, whenever the data valid value is enabled in the peripheral devices, at that moment only the CPU is transmitting that particular data. Otherwise, that particular value will be sending, or CPU is busy with the another activities. So, in the meantime, the CPU can process to execute the another program. So, the interface meanwhile keeps monitoring the device. When the interface determines that the device is ready for data transfer, and so that the interrupt is actually the request to the computer. So that detecting the external interrupt signal, the CPU monetarily stop whatever task CPU is performing, and then it transferring the data from peripheral devices to memory and then process the IO transfer. After that, it will switch to that previous task. In the both programmed IO and interrupt, CPU is busy for transferring the data for peripheral devices to the memory. So, how whatever we have some solution that direct memory access providing this particular solution, that there is CPU is not involved in this particular transferring the data from peripheral to memory. There is another device, that is a DMA, that is a direct memory access. In the direct memory access, the interface transfer data into and out of the memory unit through the memory bus. So, the CPU initiate the transfer by supplying the interface with the starting address, and then number of words is transferring data by the help of the DMA controller. Not in this particular information transferring, the CPU is not involved. Now, let's discuss in the explanation mode, that is what is the programmed IO. As we discussed earlier, that the programmed IO is what? In the programmed IO mode of transfer, CPU is busy. Overall, CPU is busy to transferring data from IO devices or a peripheral devices to the memory. So, actually what happened in the data transfer from in the programmed IO, the first of all, there is a IO devices there. This is the IO device, or you can say the peripheral devices there. In the peripheral devices, there is a whatever the input you are inputting the data value from the keyboard or the mouse or whatever, the IO device. When the data valid line, there is a one term, that is a data valid. Data valid is a DV. Data valid line, whenever the input device is having some data or a valid data, so the data valid line will be, this particular data valid line will be enabled. At that, there is a interface. This particular interface having two registers, that is a data register and the status register. A status register having a one flag value, that is the 1 bit flag value is there. Now, when the transferring is taking place, the first term, that is whenever the peripheral devices having a data valid line, means this data valid line shows, this is the bus actually, the data valid line shows that this particular is, I have some particular data that is valid and transferring this particular data or information to the memory. In this particular, so that DV value is 1. Whenever the DV value, means data valid line value will be 1, at that moment the interface having a data register, this data register and status register, the data register value will be enabled, that some particular data will be stored in this particular data register. After that, the data register having some value or whatever the content of this particular register or whatever the file IO transmitting to the memory, this particular file will be stored here as a data register. And then when the data register value is not clear, data register value having some value, at that moment the flag register bit will be enabled. This is the status register, that is the flag bit. This flag bit will be 1. It means what? That IO device or a peripheral device having some particular data to transfer to the memory through the CPU, because in the programmed IO, CPU is involved. So, DV equal to 1, and after that there is a data register. Whenever the data register having some value, the data accepted line will be enabled. This data accepted line will be enabled, and data accepted line will be enabled until and unless your particular data will be transmitting to the memory, acknowledge will be passed. After that, DA will be 0. In complete duration, DA accepted will be 1. After that, when the data valid value is transmitting to the data register, the one more term will be fetched, that is now the data valid value is 0. It means what? The other IO devices cannot send in this particular transmission, cannot For other devices, dv equal to 0, this particular data valid value is 0 for this particular transmission. It means what? That the other IO devices is, if want to transmit the data to the memory, during this transmission they cannot transmit. After the transmission will be completed, after the response will be acknowledged, after that other devices can transmit data or information to the memory. So this is the interface. Now after the interface, data register and the flag register bit will be 1. In that particular time, there is a data bus, address bus and control bus is connecting with the interface to the CPU. This particular data bus and address bus, data carry that particular, and address carries whenever you are putting some particular data, that particular data information address is to be stored into the memory. There is a IO read and IO write line will be enabled in this particular time when the DA equal to 1. In this time, IO read equal to 1 and IO write. IO read and IO write means what? If IO device wants to only fetch the data from the memory and read that particular data, so the IO read line will be enabled. If the IO devices wants to update the file that is already existing and fetching the memory and then update or save that particular file, in that particular time IO write will be enabled. Actually, whenever all the data will be passed here, of the address of that particular data will be passed here, this CPU will connecting with the memory and then transmitting that particular to the memory. Now, there is a data bus, IO read and IO write line is there. So, the interface is enabled. So, it is connected with the CPU and the IO read and write. It is IO read or IO write will be enabled or disabled according to the transmission. Means if the IO device is having some IO read line will be there, means some data is to be fetched from the memory only reading capability required. There is no updation required. At that moment, IO read will be enabled. And whenever we want from the IO devices to memory, there is some data to be whatever is stored there in the memory is the existing file is there. This particular data we want to try to fetch and then update that particular data, then the IO write will be enabled. The main problem in the programmed IO device to the CPU on the programmed IO transfer, CPU is always busy to checking the flag. This particular flag, if 1, then it means there is some data valid value is there. If the flag is 0, it means there is no data value is transmitting from IO device to memory. So, in this particular transmission, CPU is always busy. So, how we will overcome? Because the CPU is also involved in various activities. So, how we will overcome this problem? There is one solution is that interrupt initiated IO. In the interrupt initiated IO, it means that whenever IO device is having a data, then at that moment only the CPU will transmitting the data. CPU is not busy to always checking that particular data. Or CPU is not always checking the status register flag that if there is a IO peripheral devices is having a particular data or not. So that the CPU is, that's why it is called interrupt initiated IO. Interrupt means break that particular whatever is performing CPU operation. So, in the interrupt initiated IO, there is 2 types, that is a vectored interrupt and the non-vectored interrupt. In the vectored interrupt, there is a source that interrupt supplies the branch information to the computer, and this information is called the interrupt vector. In some computers, the interrupt vector is the first address of the IO service routine, and in the non-vectored interrupt, the branch address is assigned to a fixed location in memory. Now, in the programmed IO, CPU is always busy. Interrupt initiated IO, CPU is busy, but in that particular time, only whenever the data is available to transferring the memory, in that particular time only the CPU is busy. But in the programmed I/O, interrupt initiated I/O, in both, CPU is involved for the peripheral to memory transfer. For this particular problem, we will overcome by the DMA, direct memory access. In this direct memory access, CPU is not involved with the peripheral devices to the transferring to the memory. So, the transfer of data between a fast storage device as a magnetic disk or a memory is often limited by the speed of the CPU. So, removing the CPU from the path and letting the peripheral devices manage directly to the memory is provided by the DMA. So, in the direct memory access, instructions that are read from the memory by an IOP are sometimes called the commands. So, in this particular transmission, direct memory access is the phenomenon. There is a DMA controller. This particular device is tangible, and DMA controller is taking the responsibility that how the peripheral devices will be transmitting their data to the memory. Now, in this particular diagram, you can see there is a CPU. In the CPU, there is a bus request, two signals are there, that is bus request and bus grant is there. In the bus request, what will happen? In a bus request, whenever the peripheral devices having some particular data, suppose in the peripheral devices some particular data is available or a data valid line is value, but they wants to transmit some data to the memory. In that particular time, this particular information goes to the DMA. DMA transmit that request to the CPU that I just want to transmit. DMA says that I just want to transmit data, and so that you should be go into the high impedance state at this particular time. So, there is a two signals, that is a bus request and bus grant. In the bus request, what will happen? Bus request is actually coming from the DMA. And how DMA gets the request? DMA gets the request from the peripheral devices. And the bus grant, CPU provide the bus grant to the DMA or a DMA controller. So, you can see that there is a DMA transmit a bus request to the CPU. In this particular time, bus request equal to 1. And actually the IO device transmitting particular request to the DMA that they want to transmit some data or read some data from the memory. At that particular time, DMA send data to the CPU. Not data actually, it is simple request. And this particular CPU, if the CPU is not busy, if the CPU busy at that moment, so at that particular time, CPU transmit the request that in this particular time BG equal to 0. There is no bus grant. After that, the CPU complete its whatever task is doing. At that particular time, CPU transmit that particular BG equal to 1. In this particular bus grant, and always bus grant is coming from the CPU to the DMA controller. And when the CPU transmit this bus grant, then at that moment, all the address bus, data bus, read and write lines, all the lines are in the high impedance state. What is the meaning of high impedance state? High impedance state means that all the values are in the open circuit. There is no significance of the output. So, all these things is in the high impedance state. At that moment, DMA controls the IO transfer. Now, this is the block diagram of the DMA. In this particular, you can see there is this is the DMA controller. This particular box is the DMA controller. There is a data select, or you can say DMA select is there, register select, read, write line and bus request, grant and interrupt is there. This particular DMA controller is connected with what? With the IO device. IO device transmitting the request to the DMA request. In this DMA request, whenever the DMA select value is there, so at that moment, whenever the DV equal to 1, DV equal to 1 means data valid line coming from the IO device, that there is some read or write operation should be performed to the for the memory. At that particular time, this particular IO device transmitting the request to the DMA request, and so D is equal to 1. This DS, DMA select value will be 1. So, the IO device send request to the DMA. DMA at that moment, DMA send the request to the CPU, and then CPU sends the bus grant. At that moment, whenever the CPU or DMA gets the bus grant, as a bus grant value is enabled. This BG equal to 1 means bus grant value is enabled. Whenever the bus grant value is enabled, at that moment, all the buses of the CPU is in the high impedance state, means there is no significance of the output, or an open circuit will be there. So, all the read, write, address bus and data bus is in the high impedance state. Next is the register select. Actually, the DMA controller having a 3 register, that is the address register, word count register and the control register. This address register contain whatever the IO device transmitting any file, and this particular file may be stored or a fetch from that or for the updation. This particular file address will be contained by the address register. Word count register, this word count register, that total number of words present in that particular file is as a word count register. This particular word is not saying that there is a 1 bit or whatever. Word count means how many words are there in that particular file. Maybe as a 1 word can be considered as a 16-bit. Control register control the whatever the DMA request, bus grant or the DMA acknowledge, whatever the signals are transmitting, all these particular values will be controlled by the control register. If the control register is 0, so there is no transmission will be taken place. If the control register is enabled, means CR equal to 1, so that the IO device transmitting send the request to the DMA, and DMA send to request to the memory directly. Whenever this particular is going to in the high impedance state, at that particular time CPU is not in the scene. Now, in the transferring of information, CPU is not in the scene, only the IO device is there, and then CPU and then DMA is there, and DMA to memory is connected. Now, there is a BG equal to 1. BG equal to 1 means this particular BG equal to 1 is coming from what? It is coming from the CPU to DMA. CPU to DMA, that CPU is sending the particular information that now I am in a high impedance state, and DMA will be the overall responsible for the IO transfer, or a IO transfer means there is a IO device transmitting the data to the DMA, and DMA transferring the data to the memory. Whatever the read or write operations performing, all these particular is going to the memory. And the one more term is there is a interrupt. In the interrupt, hardware programmer, if want whatever IO transfer is going on, if the interrupt is enabled, means IEN flag equal to 1 in the DMA controller, if the interrupt enabled flag is equal to 1, it means whenever the transferring the data, the particular user can interrupt. Otherwise, if the interrupt value is disabled, until and unless all the transmission will be taken place, the other transmission will not get over that. This is the interrupt. So, interrupt value is may be possible, that is a 0 or a 1, means enable or disable. Enable means what? That we can handle the interrupt, means if you are transmitting some data from IO device to DMA to memory, at that particular time this particular cycle will be going on, and IO is waiting for the acknowledgement. At that moment there is some interrupt is there, because DMA is saying that I can handle the interrupt value is 1. In this particular time, other IO device can also transmit the request for memory transfer. But if the interrupt value is disabled, interrupt equal to 1, in this particular time, other IO devices cannot be transmit the data until and unless all the data transmission which is previously is going on from IO device to DMA to memory is completed. There is these registers are what, and the one more is there, word count register. Suppose that word count register having a value of 100. Word count value is whatever the word count content, that is the total number of words which you are going to transmit in a file. So suppose that there is 100 words are there. So the number of words in a file, every time when the DMA is transmitting data to the memory, in this particular time, word count register is decremented, WC -1. In that particular time, word count register will be decremented. When this particular decremented is value is going on, word count register will be when the 0. At that particular time, word count value is when the 0 means what? All the transmission is taking place. Whatever transmission is going on from IO to DMA to memory, all the transmission is taking place. At that moment, operation will be ended or a operation will be closed. This is the overall DMA controller. We can see there is a control logic control or a DMA controller is there. There is a data bus buffer is there. This data bus buffer is connected with the data bus. There is an address bus buffer is also there. This address bus buffer is what? This address bus contains the whatever the file you are going to transmit, the address of that particular, and the address register, word count, total number of words stored in that particular file which you want to transmit, and the control register control all the over the operations. If the CR value is 1, then transmission will be taken place. If the CR value is 0, then the transmission will not be taken out. So this is the overall DMA controller. So we can say the DMA controller is a hardware device that allow the IO device to directly access the memory with a less participation of the processor or a zero participation of the processor, because at that particular time CPU will be in the high impedance state. There are 3 registers are there, that is a address register, word count register and control register. The address register contain the address to specify the desired location in the memory. Word count, that is a total number of words to be transferred from IO device to memory. Either it is for the IO read or write, doesn't matter. And the control register specify which particular transferring mode you are applying. So all the register in the DMA is the CPU as IO interface register are there. Now this is the DMA block diagram, DMA transfer. The previous one was the DMA controller, and this is the DMA transferring. How there is a DMA controller. In the previous one, we are reading this particular diagram as a DMA controller, the complete DMA controller, how it is to be transmitted. Then how the DMA will be performed, that is a direct memory access is there. This is the complete block diagram of the DMA. As we discussed, the first of all, when the IO device having some data valid line, that is some data is there as transmit to the memory, that is there is a random access memory or whatever the memory is there. In the peripheral devices is there. Peripheral devices is what? That is the IO devices. And then it sends the request to the DMA request. In the first step, it sends the request to the DMA request. When the DMA finds that DV equal to 1, means there is some data is there, at that moment, it transmit a bus request enabled BR equal to 1 to the CPU. That, this means what? This BR equal to 1 says to CPU from the DMA that IO device is having some data to transfer to the memory. Either it is the IO read or a IO write. At that particular time, if the CPU is not involved or not busy to the other systems, other devices communication, at that moment CPU transmit a bus grant as a BG equal to 1. In that particular time, when the BG equal to 1 or a BG is to be enabled, at that time this particular BG, if the BG is enabled, it means what? The CPU goes to the high impedance state, that all the address bus, data bus, read line, write line, all is in the high impedance state. Now CPU is not involved in this particular transfer. Now DMA controller having all the responsibility to transferring data from IO device to memory. Either it is IO read or a write. So IO device to transmit this data to the DMA controller, and now DMA directly transmit that particular data to random access memory or a memory without any interruption by the CPU. Interrupt, as we already discussed, if the DMA controller having a enabled value, that the other devices can be interrupted. Otherwise, if the interrupt is not there, interrupt value is disabled, at that moment other IO devices during that particular transmission cannot be interrupt on that particular transmission. Now in this particular time, IO devices transmit the request to DMA request, DMA send the request to the bus as a bus request to CPU, and then this particular CPU transmit the request to the DMA controller as a bus grant, that now I am in a high impedance state, you can control all that particular data, and that particular time DMA having all the control, IO transmitting the data, read or write line will be enabled of the DMA controller, and then this particular line, read and write control line, will be connected to the memory. These are lines will be enabled and the transferring will be taken place. After that, after the transmission, the DMA will be acknowledged to the IO devices. At that moment, when the DMA acknowledge, means complete transmission will be taken place, the DMA gets that WC equal to 0, means word count value will be 0. At that moment, the CPU will be in the normal state. So, as a summary point, we can say that the modes of transfer is a programmed IO, interrupt initiated IO, and a direct memory access. In the programmed IO, CPU is always involved. In the interrupt initiated IO, CPU is involved whenever the data is available from the IO device. But in the DMA direct memory access, CPU is in the high impedance state, DMA taking the control for the IO transfer. These are the some DMA operations which we already discussed, that at the starting the IO will be there, executes the instructions and load the memory address register, whatever the word count, means total number of words will be there. Then read or write, whatever the read or write line will be performed, all the commands will be taken place. After that, this particular input devices transmit the request to the DMA. That particular DMA controller contain the as a data register, there is some data buffer is there, all the input which is coming from the IO device will be stored here. After that, this particular memory address will be written as a memory address register, and there is a word count register will hold whatever the total number of words in the memory. After that, if the WC will be 0, means word count register will be 0, at that moment it means all the transmission will be taken place. If the WC value is not 0, then again the transmission will be taken place from IO to DMA to the memory. How we will get the output? Output will be coming from the memory transmitting that particular value, and always WC value will be decremented, word count register value will be decremented, and then after that this is the disassemble the word. When all the transmission will be taken place, then memory transmit the acknowledge to peripheral devices through the DMA controller. There is two more methods are there. There is a cycle stealing. Actually, the cycle stealing method, CPU is usually much faster than the DMA obviously. So, the CPU uses the most memory cycles. So, DMA control steal the memory cycle. Actually, it steals the one memory cycle to the CPU so that it transfer data from peripheral device to particular memory. For those slow CPU, DMA controller may steal most of the memory. So, cycle which may cause CPUs all remain idle long time. And if the CPU is very fast, at that particular time DMA only steal one particular cycle. Thank you.